Hello guys, welcome to all of you on my YouTube channel. This is Samadhan Kale. So guys, we have started this linear algebra course. So in this course guys, we will see the remaining methods of the matrix guys. Okay. So I will cut this some cells, okay, that I have run previously. Yes. Okay guys. So let us import first the library, our library, that is a Sympy library. Okay. So I have import this Sympy library and it is as sy. Okay guys, now I have imported it. Now I will import guys from this Sympy library. I will import the matrix. Okay, so from Sympy import matrix. Yes, import matrix. So this is I want to import it. So this matrix is defined as capital M. Yes, so I have imported it. Now guys, I will take the today's matrix as A is equal to, okay. So my matrix is guys, now I will construct a matrix in a different way. Okay. So matrix, this is my matrix. I have told you the one way. Now I want to construct a 3 cross 3 matrix. So I will give 3, 3. Okay. This is for matrix and I will give all the elements of this 3 cross 3 matrix. That means 9 elements in this particular list. Okay. So I'm giving as 25, then 15, then minus 5. Okay, and then 15, okay, then 18, and then 0, yes, then minus 5 again, then 0 and 11. Okay guys, so this is my matrix and if I want this matrix A, so I can get this matrix A. Yes, so this is my matrix guys. Okay, so we will apply the methods on this matrix A. Okay, so today's first method guys, characteristic polynomial. So how we can find the characteristic polynomial of the particular matrix. So in mathematics we have find this characteristic polynomial by using the formula determinant of A minus lambda I. Okay, so here I have to use what I have to use guys, a dot characteristic polynomial, that is CHR POL. Yes, y CHR POL y. It is a characteristic polynomial, and if I run this guys, so I will get this is the characteristic polynomial of the matrix A. Yes, so this is the characteristic polynomial. What it computes guys, characteristic polynomial will compute the characteristic polynomial of the given matrix. Okay, now so today's second method, okay, I'm giving this method as second. Yes, its name is characteristic polynomial. Okay, so how we can find the characteristic polynomial? Yes, by using the Sympy library. So I'm using this short form. Now the next method is guys Kolesky method. Yes, Kolesky method. So Kolesky method. So by using this method, guys, what we will conclude. So this method decomposes an Hermitian positive definite matrix into lower triangular and its conjugate components. So what this method gives us, it will decompose the Hermitian matrix. That means the matrix should be Hermitian and positive definite matrix. Okay, so that matrix will be decomposed into the lower triangular matrix and its conjugate components. Okay, guys. So I have taken this matrix A, and obviously it is a Hermitian matrix. Okay, now I'm going to use the Kolesky function on it. Okay, so this is the Kolesky. Okay, so Kolesky, if I use this, so let's see what will happen. One second, I have to give here L. Yes, so let's run it. So I will get this is the matrix and this is the Kolesky matrix. That is, this matrix is decomposes into the lower triangular. Yes, let us see. This is the lower triangular matrix and its conjugates are components. Yes. Now, if this Hermitian is true and if you want to see, you can see. Okay, this is Hermitian is true. And if we take this Hermitian is false, then what will happen? Let us see. Okay, let's see what will happen if I take this as a false. Yes, and let's run it guys. So again, it will give me the same matrix. Okay. Now, next method is, guys, Kolesky solve. Okay, Kolesky solve. That means what it will give? It will solve the system Ax is equal to B using the Kolesky decomposition method. Okay, so Kolesky solve. By using this method, we can solve a system Ax is equal to B. So I'm writing here. So this Ax is equal to B. Yes, it's equal to B. This system will be solved by using this method, Kolesky underscore solve. So for that, guys, I want another matrix. Okay, so I'm taking here B as a matrix. B is equal to, I'm taking the matrix as this is my matrix, that is one column only. So 1 and minus 1 and 2. Okay, so this is my matrix, guys. Now this is only one column in this matrix. Now I'm going to use the Kolesky method on this matrix A. So I will use A dot, okay, Kolesky solve. Yes, so Kolesky solve. So this is the Kolesky solve, guys. Yes, Kolesky solve. Now in this Kolesky solve, I'm giving this matrix B and run it. So it will solve the system of this equation Ax is equal to B, and I will get the solution set that is 1 of 181 upon 675 and so on. Okay, so this is the Kolesky solve method. Now next method is, guys, cofactor method. Okay, so cofactor. So what is the cofactor? That means we can find the cofactor of each element, cofactor of each element by using this method. Okay, so it will calculate the cofactor of each element. That means element that we have to enter. So I'm using this A dot. Okay, so cofactor. Yes, so this is our cofactor, guys. So in this cofactor, I have to give the position of the element. Okay, suppose I want 0 1th position elements cofactor. Okay, 0 1th position elements cofactor. So I will get it as minus 165. And let us see, guys, where our matrix A. This is our matrix A. Not this, not this. This is our matrix A. And if we do this, so we will get 165. That is, sorry, minus 165. It is the cofactor of the 0 1th position element. That means 0th row and first column. Okay. If you want to find the cofactor of the first element, that is, yes, what is that is 0 0. Yes. So you can find this cofactor of 0 0, and it will give you the cofactor as 198. Okay, guys. Now, if you want to find a cofactor matrix, this is a single cofactor. And if you want to find a cofactor matrix, then there is a method known as a cofactor matrix. So by using this cofactor matrix method, we can find the cofactor of the matrix. Okay. So cofactor underscore matrix is the method, guys. So by using this method, we can find the cofactor of the matrix. So let us see, apply on this cofactor method. Okay. So I'm going to apply this cofactor method. Yes. I'm going to apply this cofactor method on this. Okay. So this is the cofactor matrix. Okay. And let's run it. So I will get the cofactor matrix of the matrix A. Okay. So for understanding purpose, I'm going to take here the matrix A so that we'll understood the A and cofactor of the A. Let us see. So this is the matrix A and this is the cofactor of the matrix A. Okay, guys, I hope all of you understood the method. Now, let us see the another method. 1 second. Yes, I'm going to take the another method now. Yes, that is column method. Okay, that is a column method. If you want a column or elementary column, particular column, you can take the column of the matrix. Okay, so I'm using this column method. Okay, so column method. Let's apply this column on this. Okay, so A dot call. Okay, A dot call. So if we run this, so we will get error. So if I have to give here argument, I want the first column, that is the 0th column. So I will get this 25 15 and minus 5. If I want a second column, okay, then it will give me the second column, yes, from the matrix A. So this is the column selector method. Okay, now I have taken already in the previous videos, that is column delete and column taken. Okay, so I'm going to take that in short. Okay, so next one is a column delete. So which column you want to delete, you can take this column delete. And suppose I want to delete a zeroth column from the matrix A, so I can delete it. Okay, and if I take the A, then it will delete the first column from this matrix A. Okay, now if I want to insert column insert, okay, so I have to use the column insert method. So call insert, yes, and which column you want to insert, or insert one or more columns at a given column position. You have to given the position here. Okay, so if you want to take, you can see here, you have to give the position here itself. And what is the position, guys? Let's see. So this is the position that you have to give. That means where you want to insert this column, at position 1 or 2 or anywhere. Okay, so this is the information. Now which column you want to insert? Okay, so my column, which column I have lost, 25, 15 and minus 5. Okay, so I'm giving to this column as v is equal to, this is the 25, then 15 and minus 5. Okay, so these elements I want to add, so I'm giving this, store these elements in the v. Now I want to add these at position 0, and which elements? V elements. Okay, and if I run this once again, what's happening here? Okay, list object has no attribute rows. List object has no attribute rows. Okay, so I will convert this into the matrix. Okay, that's why it will convert it into the column. Okay, so let's run it. So it will add it 25, 15 and minus 1. Okay, guys. So this is the column insert method. So by using this method, we can insert a particular column at a particular position. So next method is, guys, column join method. So we can join the column also. Okay. So this is the column join. So by using this method, we can concatenate two matrices along the cells last and others first row. Cells last means the matrix last and others first row. That means if you want to concatenate two matrices, so we can concatenate them by using the column join. Okay, now A matrix I have, I want to add some another matrix B. Okay, so I'm going to take this matrix as matrix. Again, I want a 3 by 3 matrix. Okay, and then I want this 1, 2 and 3, then minus 1 and 0, and then 2. Okay, and then again 3, then minus 2 and 1. Okay, so these many elements I want in the matrix B. Now I'm going to print this matrix B. Okay, so it will give me the matrix B. Okay, column join method. So I'm going to use this column join method. So I am using a dot column join. Okay, column join. So which matrix you want to join? So I want the matrix B join. So I will get this one. So let us see what is happening. Self and others must have the same number of columns. Okay, so it has 2 columns, and matrix A has how many columns? Let's see if this inserted or not. Yes, so it has 2 columns only. Okay, now if I run this and then again run this, again it's deleted. Okay, now I will take this matrix A again. I will run this cell again so that it will be inserted. Okay, so this matrix I have to insert. Okay, so this is inserted. Now I will insert this and run. Now it will give me the firstly matrix A and then matrix B. So what is column join, guys? It will concatenate two matrices along cells last and others first row. That means at the last row of the first matrix, the second will be started. This is the column join method. So next one is a column swap method, guys. Which method? Column swap. So column underscore swap. If you want to swap the columns, you can swap it by using this method. So we can swap the two columns of the matrix in place. Okay. So a dot column swap. Okay. If you want to check what is in this method, you can check. You have to give the I and j. Okay. Which column you want to swap. Suppose I want 0 and 1. These columns I want to swap. So if I print this A again, then I will get the columns 1 and 0 are swapped. Let's see this 25, 15 and minus 5. This is the first column in the previous. Now it will go to the second column. Okay. That means I have swapped the two columns. Okay, guys. Now next method is the column space method. I'm going this method I'm going to taking serially. Okay, that means a C and then D and then E and so on. Okay, serially I'm going to take this method. That's why it's number of column space and column join and all these thing cofactors. Okay, so next method is, guys, column space. How we can find the column space of the matrix. Okay, so in this method, you have to apply a dot column space. So it will return, guys, the list of vectors that spans the column space of M. Okay, all of we know in the mathematics there is a column space. So this is a column space method, and if I run this, I will get the column space. That is this is the first vector. Okay, 15, 18 and 0. Second vector is 25, 15 minus 5. Third vector is minus 5, 0 and 11. Okay, these are the column space. Now, next method is, guys, companion. Okay, so companion matrix. So it will return a companion matrix of a polynomial. Okay, so if you want to find the companion matrix of particular polynomial, you can find a companion matrix also. So for that, guys, I have to insert particular polynomial. Okay, so there is a poly function in the Sympy library. So firstly, I import that poly function. Okay, so from Sympy, I'm going to import the poly function. Okay, so import poly. Okay, and you want a symbol also. Okay, so symbol function is there, so you can use this symbol. Okay, symbol, so that you will apply this on the symbols. Firstly, now you have to define the symbol x, which in which variable you want the polynomial. So I want the polynomial in x variable. Okay, so I'm going to use this x is equal to this the symbol of the x. Okay, so symbols is there. Now how I want the polynomial. I want the polynomial. So I'm going to take p as a polynomial and I'm using this poly function. So this poly p is capital, guys. Okay, remember this thing. So it is capital poly, and I'm going to print the polynomial. Which polynomial I want? Suppose I want this x square. Okay, so x square, then plus I want 3x. Okay, 3x, and then plus 2 I want. Okay, so this is my polynomial, and if I run this, so I will get the polynomial p. Okay, here I want to take the p, and I will get this polynomial x square plus 3x plus 2. Okay, now I will find the companion matrix of the polynomial. Companion matrix of the polynomial. So I'm going to use a dot. Okay, so this is the companion. Yes, so it will give me the companion, and you have to give the polynomial. So it will give you the companion matrix of the polynomial. Which polynomial? This polynomial. So this is the companion matrix. 0 minus 2 and 1 minus 3 is the companion matrix, guys. So next one is next method is, guys, condition number. Okay, so you can find the condition number of the matrix. So it will return the condition number of matrix. What is the condition number, guys? The condition number is the maximum singular value divided by the minimum singular value. Okay, so it's the condition number. So by using this condition number method, you can find the condition number, okay, of the particular matrix. So what is the condition number, guys? Condition number means the maximum singular value divided by minimum singular value. Okay, so I'm going to take this condition number. Okay, so it's first one, condition number, and run it. So I will get the condition number. 1 second, what's happening? Okay, now I will take another matrix. Instead of A, I'm going to take the B matrix, and I will find the B matrix condition number. Okay, again it's giving me error. It's not comparable. Okay. Okay, guys, I will define another matrix for this. So S, I'm going to define S is equal to, I have defined this matrix as I want suppose 2 by 2 matrix, and in this 2 by 2 matrix, I'm going to take the elements as 1 and 0, and then 2 and -3. Okay, and then I will use this on S. So it will give me the condition number. So this is the my condition number, guys. It's a square root of 2 root 10 plus 7 upon square root of 7 minus 2 root 10. What is the condition number? That means it is the maximum singular value. Numerator is the maximum singular value, and denominator is the minimum singular value of the matrix S. Okay. Now, next one is a conjugate kinds. Okay, so we can find the complex conjugate of each element in the matrix. Okay, so by using the conjugate function. So for that conjugate one, I want the complex matrix first kind. Okay, so I'm defined this C as a complex matrix. Okay, so I will define this matrix. So for that, guys, in the complex matrix, you want the I. Okay, x plus iy, the complex number in the form of x plus iy. So in this library Sympy, there is a I. Okay, so I'm going to that I, taken that I. So from Sympy, I will import this capital I. Capital I means imaginary number. Okay, now I'm going to construct a matrix. Okay, so I want a 3 cross 3 matrix, and then I will take the elements, same elements I'm going to take. Okay, so firstly I will take this 2i. Okay, 2 into I. Then second element is 1 plus 2i or 3i. I'm going to take. Okay, 3 times I. This is my second element. Third element is 1. Then next element is 7. Then next element is -7 minus times I. Okay, and then next element is 2. Okay, how many? 2, and it's 4, 6, 7. Okay, then 1, and last one is 1 minus I. Okay, this is my matrix, and I'm going to take this matrix C. So let's see, it will give me. Okay, 1 second. The elements, how many 9 elements you want? 2, 4, 6, 7, 8. Okay, one element is remaining, and then I'm taking this as I. Okay, so this is the matrix, guys. This is C matrix, and I want to find the conjugate of this matrix C. So I will use the function as a complex conjugate. Okay, so this is the conjugate, guys. So conjugate, A dot conjugate. So I will get the complex conjugate of this matrix. So let's see. Not this one. I want to C matrix. I'm taking A. Okay. So let us see. This 2i becomes a minus 2i. 1 plus 3i becomes 1 minus 3i 7, and this minus I becomes plus, and we will get the conjugate matrix. Okay. So this is the conjugate matrix. So next method is, guys, connected components. Yes. So which method? Connected components. Let us see what is this connected components and what it will be written. So what is this method, guys? It will return the list of connected vertices of the graph. List of connected vertices of the graph when a square matrix is viewed as weighted graph. So we have the square matrix, and if the square matrix is viewed as uh, weighted graph. If it is viewed as a weighted graph, then it will give, this method will give us a list of connected vertices of that graph. Okay, guys, you have already known in the mathematics graph theory, that is adjacency matrix and incidency matrix. Okay, so if you want the connected components of the particular graph, so by using this method, you can get that connected components or connected vertices of the graph. Okay, so if I am taking the connected vertices of the matrix A, of the matrix A, yes, so connected components, connected components, and if I run this, so I will get, these are the connected components. That means 0 vertex, 1 vertex, and second vertex. These are the connected components. Okay, guys. So this is the connected component method. And the last method is, guys, for C, that is a copy method. Okay, that means it will copy the same matrix. So if I will use a dot copy, so the matrix is get copied now. Yes, here it's so 15, 18, and 0, and this one. This is get copied. So I hope, guys, all of you understood the C type methods in this library matrix. Okay. Now in the next lecture, we will going to see the D methods in the matrix. Okay, starting from D. So thank you for watching the video.